Hey guys, welcome back. Let's see today's question. Yep, let's start always with the lead code and let's see what is this. Destroying asteroids. Okay, you are given an integer mass which represents the original mass of planet. You are further given an integer array asteroids where asteroids of I is the mass of the I asteroid. Okay, and you can arrange for planet. So okay, you can arrange for the planet to collide with the asteroid in any order, in any arbitrary order. If the mass of the planet is greater than or equal to the mass of the asteroid is destroyed and the planet gains the mass of the asteroids. Otherwise, the planet is destroyed. Return true if all asteroids can be destroyed, otherwise, return false. So, this is the mass of the planet 10, and these are the asteroids. So, one way to order is like 9, 19, 5, 3, 21. Let's see how. So, the planet collides with the asteroids of mass 9. Okay. New planet became 19. Got, got it. Now, what? The planet collides with the asteroid, a mass 19, and the new planet become 19 plus 19, 38. Now, the planet collides with the asteroid, uh, a mass of 5, new planet mass become like 38 plus 5, 43, and so on. Okay, so it says it's possible, but for 5, it's failing because if we put 4 before, okay, then it becomes 9. So, you know, we can put 9, then it becomes 18. And then we can put 4, it becomes uh, 22. That is why it's failing, right? So, to solve this question, we need, uh, you know, the greater elements which are smaller than the mass should come first. Okay. For example, here we have greater element less than 10, which is 9. So we put there. Then when we put that particular number, then our mass is changed. Now we need someone, uh, you know, uh, someone which should be lesser than greater but lesser than the new mass, right? In this case, 19. So new mass is 19 and we can get asteroid of size 19, so how it's all about arranging, right? So we have to make sure that we are arranging it proper and to get the desired result. Okay, so how to solve this now? uh what if we what if we uh sort in the increasing fashion? Okay, so first it becomes 13, then you know we can add 9 into it. And yeah, seems like what happens if we just put the asteroids in just a sorted array. Okay, so here you can see we will have 3, then 9, 3, then 5, then 9, let's say. So it will become like 10 plus 13 plus 5, and then plus, no, then it becomes 18. But and then we add 9 into it, then it becomes you know so what if just we sort the asteroids? That is first coming into my mind. Let's see what happens. Okay, and for int I, let's say asteroids, and if mass is less than asteroid, return false. Otherwise, our mass gain, right, and return mass, return true if this happens. So let's see what happened. Asteroids. Sorry, I will not sort. Let's try to submit and then check what happens. So we have a wrong answer for this particular case. We have mass like, okay. So probably we have uh okay, we can, let me test. Is this happening because of limit exceeding with the integer? Okay, let's put long, or let me check array of size, and everywhere we have this. Let's check with the long uh dot of mass. Let's say initially we have mass. Okay, okay, let's see. It's accepted. Okay, and let's see the GFG question. So what it does, express consecutive number sum, meaning we have to just check that the consecutive number sum is this particular can be a consecutive number sum. Okay, and how we can do that? So how we can do that? Either the number itself can be a consecutive, but let me check. Find whether the n can be expressed as a sum of two or more consecutive positive numbers. So we need two or more consecutive positive numbers. And if you carefully observe, uh, for n is equal to 24, if we need two numbers, okay, those should be, below n by 2, right? if we, let me show you, if n is 24, okay, and we need two numbers, x plus y, two or more numbers, let's say, which gives this result, right? But to make sure this happens, our the biggest number, okay, among these should be uh you know this 24 by 2, well, right? So the biggest number should be 12. Either we can to get 12 12, or you know 12 then other number smaller than this, okay, then and then it works, okay. If you try to get the 13, then it fails, greater than 12, so it becomes 25. So this is not going to be our answer, okay. So the one biggest element that we can get, which is n by 2, right? For this case, n by 2 is 5. Either we can take 5 and then uh you know 5 then the below elements. So actually, when we are taking the below elements, okay, you can go consecutively, like take 5, then try to take 4, then take 3. If this is failing, then remove this 5, then check, then check. If it's giving the answer, then good. Otherwise, remove this last element. Since we are, you know, let's see what happens. Okay. So first, our max element will be like n by 2. Okay. So this is our max element, and let's say if n is 11, let's say, then how we can achieve this? We can achieve like 6 and 5, right? So if we do 11 by 2, it will come to the 5, but the maximum that we can get is 6. So we can have something like n plus 1 by 2, the max element that we can get. Now, uh, you know, you can track like our current sum, you know, current sum, which is, let's say, 0, and int last element, which is our max. Okay. So while max is greater than 0, greater than equal to 0, let's say, you can take things like current sum plus equal to max. If current sum, you know, uh, is going greater than n, okay, or you can say if it's equal to n, then return true. Otherwise, if current sum is greater than n, we need to remove the last element, right? Minus equal to last element, and then last element will become uh, the one left side, right? And yeah, something like this. And at last, we will return false. Okay. So for 24, let's say our max element is 12. Now we try to get 11. Then, you know, let's try. We have 12. Then we try to get 11. Our desired result is this. So it becomes 3 and 2. Then we try to get a 10. Then it's exceeding. It's become 3 3. So we remove this part. Okay. And it goes for this one. So when we remove this part, then it becomes like uh, 21. Now we put 9 into it, then again it's exceeding. We cancel this one from the sum, then it becomes uh, you know 19, and then 8. Again we remove this one, then 7, and this you know s- uh, how much this became? Be 17 plus 7, it becomes 24. So this is our answer. Now 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 let's see. Since the max will be always greater, we have to track for the last element. That is what we were going to decrease, right? Let's try to submit. What's what's happened? Greater than 0 for 7. Let me check what happened. 7. The expected is false. So let me see for 7. What are these two numbers? So since we do 7 plus 1 by, it becomes like 4, and then it becomes 3. This is 7, right? 4 and plus 3. Okay. We need to add, we need to, you know, go to the left direction with the max also, right? So we always need to reduce our max. Okay. So this max will, we'll try to get new, and then be tracking the last one. Okay. And let's see what happens again. For 1, it should be false because there is only one element, and we are trying to add 1 into it and checking if it's true. And also we need to check the last element not equal to max. Okay. Let's check for 1 also. This is not good. Again, it's giving true. Mm, okay. Last element in this case is 1, and our max is also 1. So max minus minus, and then it becomes true. Max is equal to, what just happened? Okay. Mm, we are we are going. This is our head. Okay, that we are introducing new number, and this is our last. Okay, so we need more than two items. That for sure, and we need uh, we need well, max is greater than zero. Okay, and here I think we need to uh, check that we at least contain two elements, right? So let's say this is variable for now. Uh, how many elements we have so far? So this is one, and this is zero, and this is plus plus. We need CND more than one at least. So yes, we have our answer, but let's check another test case. The big number. What is this? Okay, seems like it will work. Okay, time limit exceeded. So now we need to improve our time also. How? So it's sort of linearly happening all things, right? Mm, we need consecutive stuff also. Okay. Now how to do this? We need to return either true or false. Actually, uh, we are not, we are not returning the numbers. Okay. In that case, we just need to think about the mathematical way. Okay, about the possibility, will it happen or not? Okay, for example, we have to check uh, if it's even, odd, and second case, what happens if it's even, then can we get that particular result or not? Okay, in mathematical term. So let's say we have 24. Okay, this is even numbers. Then again we have 26, which is even numbers. So we know we can achieve this 24. Let's say, can we achieve 26 also? So let's say this is 26. We can try divide by 2, which becomes 1, 3, 13. Then we can have 12, which becomes 25. Not happens. Then 11. Then, you know, it becomes 23 again, like this. 21, 9, and you know 9, 8. So 8, 9, 10, 19, 19 plus 8, which is 27. No need. So this, it becomes 24. Now we cannot go further, okay, because we are not going to achieve it, right? So when we were at 24 and then when we try to add 6, it gives a smaller result, I guess. So 14, 15, and then 6, which is 21. Then if we try to cancel this much, it becomes more the smaller number. Okay, we have to check here if uh, current sum is uh, okay. Uh, what I was doing is just taking only 3 numbers, but we can do any consecutive. So here the answer is 24, right? So we remove this part. Then here it becomes 15, 8 plus 7, 15, and then 6, which is 21, and this 5, 26. So we can achieve, let's assume that if it's even number, then we can achieve. For example, if it's 2, then what should be the 2 itself? What if 3? So 1, 3, we can achieve. What if 4? Then 2 and 3, which becomes 5, not 4. So 2 and 1, 3. This 4 is not going to, you know, we cannot have consecutives for the 4. Again, is this some sort of factor-wise that we need to get factors? Let's say if we try to get factor for 4, then it becomes 2, and then 2 to the 4, and then 2, and then 1. Only 2 is the factor of it. And for 26, let's say, then we have 13. So, okay, 2 and 13. For 24, 6, 3, 3. So we have these 2 factors. So if number contains, I guess, 2 factors, okay, then we can get, the desired result, I guess. Let's try for 7. The 7 itself is a number. So there is only one factor for it, okay, but 7 is a prime number. Let's say another prime, 11. Can we achieve 11? 6 and 5. Yes, 11 is a prime number. Also, for 13, can we achieve 7 and 6? Yes. If it's prime number, then good to go. Okay. And now one thing looking clear, if it's prime number, then we can go. Let's say another prime number, which is the 15, 17. Let's say 17. Can we achieve 17? So First, let's take 9 and then 8, 17. Yes, we can achieve. So, one thing clear, if prime, our answer yes. Second, if more than 2 factor, answer yes. Otherwise, no. Let's try. So, 10 to the power 9. So, let's okay. N can be anything. Let's check the factor wise. Okay. Uh, 2, 3, and so on, right? That's the factors we have so far. So, let's say 5 and not equal to 0. N is greater than 0. Two factor plus and n divided by equal to. Okay. Then if n is greater than 1, then return true, otherwise false. Now, how many zeros we have? 9. 3, 4, 5, 6, 7, 8, 9. Okay. Let's check 17. Great. Let's try to submit. It's working. Okay. So yes, thank you for watching.